You know, in the world of machine learning, we talk a lot about fancy algorithms and massive neural networks. But there's an unsung hero, a foundational skill that powers almost everything behind the scenes. So today, we're going to build the ultimate SQL tool belt for ML. We're breaking down the exact concepts you need to know to build real production-grade systems. So, when you think about what makes a machine learning model powerful, what's the first thing that pops into your head? It's probably a Python library, right? Something like TensorFlow or PyTorch. But honestly, that's only part of the story. The real engine driving things is often something way more fundamental. Yep, the true backbone of data manipulation in nearly every single production ML pipeline is good old SQL. And you might be asking, why? Well, it's pretty simple: scale. While Python libraries are amazing, they usually need you to pull data into your computer's memory. SQL, on the other hand, lets you work your magic on millions, even billions of rows right where they live, in the database. It's the absolute key to working at scale. Okay, let's start at the beginning with the absolute fundamentals. Before you can even think about building cool features, you gotta get the right data, stitch it together from different places, and then trim it down to just what you need. Now, check this out. The type of join you choose isn't just a technical detail. It completely shapes your dataset for the problem you're trying to solve. Take a churn model, for example. A left join is absolutely critical. Why? Because you have to keep all your customers in the dataset, even the ones who haven't bought anything. That lack of activity, that's a super powerful feature. If you used an inner join, you just throw all those valuable data points away. Okay, this one trips people up all the time, so let's make it super clear. Think of it like this. Where is the bouncer at the club door? It checks every single person's ID before they're allowed in. It filters individuals. Having, on the other hand, is the manager who walks around inside the club and kicks out an entire table if, as a group, they're not spending enough money. So you use where to clean your raw data first and having to filter your final summary results after you've grouped them. All right, we've got our basic data shaped up. Now it's time for the really fun part: adding some intelligence. Let's dig into how you can create some pretty sophisticated features right inside your query. This is where SQL really starts to flex its muscles for machine learning. The case statement is basically your Swiss Army knife for feature engineering. It lets you write if-then-else logic to create totally new columns. For example, you could take a column with someone's exact age and use a case statement to bucket them into useful categories like teen, adult, and senior. It's just a really clean, powerful way to turn raw data into features that your model can actually understand. So here's the thing about machine learning models. They expect data in what we call a wide format. That means each row is one single thing, like one user, and all the columns are features about that user. But a lot of the time, our data starts out in a long format, where you have a new row for every single event. Pivoting is that crucial process of transforming the long data into the wide, model-ready format we need, usually by grouping and counting things up. Okay, now we've arrived at a true game changer. Seriously, if there's one set of SQL tools that separates the pros from the amateurs in ML, it's window functions. These are the absolute key to creating powerful time series features without writing crazy, impossible-to-read queries. So here's the most important difference you need to get. Group by literally crushes your rows together. It takes a whole group of rows and smashes them down into one single summary row, and you lose all the individual detail. But window functions, they're different. They let you do calculations over a group of rows, like a running total, but they add that calculation to every single row in the group. You get the aggregate intelligence without losing any of the original data. It's amazing. Let's meet our first window function, lag. I want you to think of this as a rear view mirror for your data. When you're looking at one row, lag lets you reach back and grab a value from the row right before it. So why is this so useful? Well, it's essential for creating features that measure change, like calculating the time that passed between users' consecutive clicks. And on the flip side, you've got lead, which does the exact opposite. It's like having binoculars to peek at the next row in your dataset. Now, this can be super useful for some things, but you have to be extremely careful here. Using information from the future to predict something in the past is a massive error called data leakage, and we'll talk more about that in just a second. And here's a perfect practical example of lag in action. Let's say we want to create a click velocity feature that shows how fast a user is interacting. First, you partition your data by user, so you're only looking at one user's events at a time. Then, you order their events chronologically. And now you can use lag to grab the timestamp from their previous action and just subtract it from the current one. And just like that, you've engineered a really powerful behavioral feature. All right, listen up because this is one of the most important concepts in all of machine learning. It's called temporal leakage. It's what happens when information from the future accidentally seeps into your training data. Your model will look like a genius during testing because it's essentially cheating by looking at the answers, but then it will fail spectacularly in the real world. You prevent this in SQL by being super strict with your dates in the where clause, making sure your feature data always comes from a time before your label data. You know, being a great data scientist isn't just about getting the right answer. It's also about writing code that your teammates can actually read, maintain, and trust. And that brings us to our last section, how to write clean, efficient, production-ready SQL. Have you ever seen a query that looks like this? It's just a tangled mess of subqueries nested inside of other subqueries. I mean, it might technically work, but good luck trying to debug it. It's impossible to understand a month from now, and trust me, your colleagues will not be happy with you. This kind of chaos is exactly why we need a better way to structure our thoughts. It's just not maintainable. So what's the elegant, professional solution that turns this spaghetti code into a clear, logical story? The answer is common table expressions, or CTEs. By using the with clause, you can break down your massive, complex query into logical name steps. It's like writing chapters in a story. First, we get the recent orders. Then, we get the customer aggregates. Finally, we join them. It makes your code self-documenting, way easier to debug, and just 1,000 times more readable. This is what professional SQL looks like. And finally, let's talk speed. Your query needs to be fast. Now, there are a lot of optimization tricks, but here's a huge one. Try to avoid using functions on your columns inside a where clause. For instance, filtering on something like year, order date often stops the database from using its index on that date column, which forces a super slow scan of the entire table. Whenever you can, filter on the raw columns. It makes a huge difference. Okay, that was a lot, so let's wrap it all up with a quick cheat sheet. If you don't remember anything else, remember these 5 points. Use window functions for any time series features. Make left join your default to avoid accidentally losing data. Write clean, readable code with CTEs. Cook up custom features with case statements. And most importantly, be paranoid about temporal leakage, always. And here's the bottom line, the why behind all of this. As the source material puts it so well, mastering SQL is critical because real-world ML jobs are all about building reproducible and efficient data pipelines. This is the skill that truly separates academic projects from industrial-strength solutions that actually work. So there you have it. You now have the core tools in your SQL toolbelt for machine learning. The only question left is, what awesome, important problem are you going to go solve with them first?